Hello friends, hello learners. Today we take chapters 14, Symmetry, class 7 Mathematics. In this chapter, we study about symmetry and its types. So what is meant by symmetry? A figure has line symmetry if there is a line about which the figure may be folded so that two parts of the figure coincide. Line is called line of symmetry and figure is called symmetrical figure. See the spacing of symmetry and its image. In between these two images, there is one line. So both are symmetrical and line is called line of symmetry. So what is symmetry? Symmetry is when an object has two or more equal sides when split in half or in smaller pieces. Symmetrical, same on both sides. Balanced proportion are capable of division by longitudinal plane into similar halves. Symmetries preserve distances, angles, sizes and shape. So there are two types of symmetry. One is line symmetry and another is rotational symmetry. We will discuss both one by one. So first take line symmetry. So line symmetry is also nothing but reflection symmetry. So reflection symmetry means when we keep mirror in front of any object, we just see the image of object as like object in the mirror. That is called reflection symmetry. So line symmetry is the same as line symmetry where one half of it is the mirror image of the other half. See the English alphabet A, and there is a one line in between the A, that is vertical line. Along this line, when we fold this alphabet A, two parts coincide each other. That is A is symmetrical figure, and this line is called line of symmetry. This is also trapezium, also same. This is the line of symmetry. When we fold these two images, these are coincide. See the man face, lips, tower. Symmetry exists all around us. Another example, butterfly. A butterfly has symmetry. If you draw a line, center of a butterfly, both sides are same. Fruits. Some fruits are symmetrical. Insects, even human being man is also symmetrical most of the time. Some mathematical plane figures like square. Square, when we draw a vertical line, it is symmetrical. Means when we fold along the vertical line, both parts coincide. Then along the horizontal line, both are coincide. And diagonal means square has four lines of symmetry. In case of circle has infinite lines of symmetry. So along the diameter, when we fold the circle, both parts coincide each other. So in circle there are infinite number of lines of symmetry. In case of rectangle, only vertical line of symmetry and horizontal. Horizontal, it means it has only two lines of symmetry. So what about this mass symbol? Do they have symmetry? Observe. This is plus sign, yes, it is symmetrical. This is minus sign, yes, it is symmetrical. It is multiplication sign, yes, it is symmetrical. This is division sign, it is also symmetrical. Now here, which of these flags have a line of symmetry? There are four flags, so observe the symmetry. This is flag of USA. Is it symmetrical? No. This is flag of Canada. Yes, it is symmetrical. Maryland flag is not symmetrical, and flag of England is a symmetrical. So all these examples of line of symmetry. So how many lines of symmetry do these regular polygons have? So what is mean by regular polygon? The polygons having the sides of equal length, all sides are equal, and having all angles having same measure. Okay. So this is equilateral triangle. So there are three lines of symmetry. This is sphere having four lines of symmetry. This regular pentagon, HU, regular hexagon having 6 lines of symmetry, and regular octagon having 8. Means number of lines of symmetry in every regular polygon is equal to number of side in regular polygon. Remember that number of lines of symmetry in regular polygon is equal to number of sides having the regular polygon. Some examples are there. This shape of rectangle, it is symmetrical. This is a square, it has 4 lines of symmetry. This is oval, only 2 lines of symmetry, vertical and horizontal. This is alphabet H, it is also 2 lines of symmetry, vertical and horizontal. Now see the English alphabets. There are 26 alphabets in English, and some alphabets having lines of symmetry, some are not. Some having vertical, some having horizontal, and some having both. See, A having only vertical line of symmetry, B horizontal, C horizontal, D horizontal, E horizontal, but F and G are having no line of symmetry. H having both horizontal and vertical, I also line of symmetry, J, K, L having no line of symmetry, M having line of symmetry, N having no line of symmetry, but here O having infinite number of lines of symmetry like circle. Here P, Q, R, S having no lines of symmetry, T only one line of symmetry, that is vertical, U having only one line of symmetry, V having only one line of symmetry, W having one line of symmetry, X having both vertical and horizontal, Y having only one line of symmetry, and Z having no line of symmetry. So you can look to see if your name has symmetrical letters in it too. Okay. So another example of another type of symmetry is rotational symmetry. So what is meant by rotational symmetry? The action of turning a figure around a point or a vertex. So what is rotational symmetry? An image has rotational symmetry if there is a center point around which the object is turned a certain number of degrees and the object still looks the same, that is, it matches itself a number of times while it is being rotated. Look at the example of triangle. When triangle we rotate through 120 degree, we look same figure as like triangle, same original triangle. Since this triangle will match itself 3 times as it is rotated, it is said to have rotational symmetry of order 3. So in rotational symmetry, we remember that we first find the center of rotation, then angle of rotation, then direction of rotation, and then order of rotation. So here rotation of equilateral triangle, this is original equilateral triangle. When we rotate through 120 degree, this position becomes, and when we this equilateral triangle, when again we rotate through 120 degree, we get this position of 240 degree. When we rotate same triangle through 120 degree, we get same position, same figure of equilateral triangle as like first position. Okay, so center of rotation is centroid, order of rotation is 3. Why it is 3? 360 divided by 120. Angle of rotation is 120, so divide this angle to 360 degree, we get 3. So direction of rotation is clockwise. Again, see one example, rotation of square. This is square. When we rotate through 90 degree, we get this position, and again through 90 degree we get same position of square, again we 90 degree same position of square, and again through 90 degree we get same position of square. So here we get order of rotation 4, and point of center of rotation is intersect point of diagonal. The direction of rotation is clockwise and angle of rotation is 90 degree. These are the example of rotational symmetry. Observe these examples. Next is translation. When we translate octagon, see the example of octagon to see the translation. Act of sliding a figure in any direction. If you slide the figure in any direction, we look see it same. That is called translation. Another is reflection symmetry. Reflection symmetry is nothing but line of symmetry, and it is also called mirror symmetry. An object is reflected across a line. Okay, now this is B. Its mirror image is like this, and this is triangle mirror image is like this. So in reflection, result of a figure flipped over a line. This is a line, suppose this is a mirror, and same figure looks in the mirror. Next is which shapes show reflection, translation or rotation. Observe these three examples. This is rotation because this figure rotate and we get this position. Another example is this triangle. This is the reflection of this triangle. Okay. And here translation. We rotate any slide any type anyway we get same position, that is translation. So this all about line of symmetry and rotational symmetry. Thank you.